So just more about myself before I jump in into the slides, right? So as Ron was saying, I worked in multiple clouds. So right now I work at Google Cloud. So today I think one thing that I wanted to talk about was there is a lot of discussion around smart analytics, right? So with the advent of machine learning and more use of machine learning and generative AI. So I want to take a step back and try to talk to you about what Google's perspective from smart analytics is and how we look at it and where all are the areas we are investing from that standard perspective, right? So even before we go there, I want to give some before we go into the tools and stuff that we have, wanted to take a step back and talk about how we are looking at the landscape itself, right? So we strongly believe that every company, whether it's a small company or a big company, eventually is a data company, right? So we we believe that the value of a company is within the data it holds, whether it could be about your customers, about the transactions, or about a landscape as a data service provider or stuff like that, right? So the summary we want to talk about here is the more data you have and the more capability you have to capture the data, we strongly believe that doing that will enable you to have a lot of analytics and insights into that, right? Again, I come from a background of a data warehouse developer back in the day, right? So one challenge I always ran into was my source systems or the data providers always had a lot of data, and we always tried to fit that into some form of RDBMS, right? Or some form of structured data. And in the process, we lost a lot of value in the data that we were getting from the source system or the data vendor. So we strongly believe that you should not do that. So rather than doing that, try to get the data as is and then try to run analytics and extract the information that you need, right? So again, as I said, we believe data is going to be the main important thing, right? So and also once you look at companies from that perspective as data companies, right, you start to see how they make decisions, right? So we have been observing like companies which are data driven and they are making decisions rather based on informed decisions, what we call them, right, based on the data and based on the facts and based on things like that. We believe that that increases their success rate from an improving decision making standpoint, right? So again, this giving you a backdrop on why we think data is important and how it can help you make those informed decisions better and give you that all the data available for you to make the decisions. It could be a CEO or it could be even a business analyst trying to come up with a dashboard, right? So what are the things that I need to push on the dashboard? What are the metrics and stuff like that, right? So that is where we think having all of that data is extremely useful. So this is very nice, right? So this is where you want to be. But what are some of the challenges that we have observed working with multiple clients at Google, with both smaller companies and enterprises, right? Few things that come to mind for me are around legacy applications, right? So this could be an application that was written in a absolute technology back in the day, right? So we don't really have the skill to do that. So we have a lot of these legacy applications, and with our monolith kind of applications which have their own data sets and stuff like that. So how do I take that data and try to generate intelligence out of that data from that application? How do I get the data out, right? So that is one of the challenge. The second one is silo. So especially this is very true when you think about a large organization which has multiple divisions. Data always was within each silo, right? So a good example, I worked with multiple customers where the this was an insurance customer, right? So they had multiple products. They sold life insurance, they sold property and casualty and stuff like that. So as a user, for me to look at both my life and property and casualty, I had to log in into the same website, but I had to, the only change was a drop down, right? So the only reason they had to do that was because the data was siloed, right? So think about how frustrating it would be for me to do that, right? So because of the data silos, one, you're not actually looking at the customer 360 degree and trying to see, okay, what can I upsell this customer, or where, what is this customer doing, what are, how can I help this customer better with my products, right? So again, data silos will again, that is one of the challenge, as I said, we are looking at, right? Again, the other view of that is each each silo or each division has their own perspective on data, on what are their KPIs, how do they think the data can be can generate some intelligence. But again, because you're not looking at it from an enterprise level or a holistic view, you're not really getting into the details of what can be done. Of course, there are a couple of other things, right? Regulatory environment. A good example for this is like you could have in a bank or an insurance company or stuff like that, where you have certain specific needs on how long you have to put this data and where you have to put this data, and can this data be used for different purposes, stuff like that, right? Again, based on where you are and how on which part of the world you are, there are different regulatory requirements. So that kind of hinder some of your strategy over there. But and with everyone moving into the cloud, right? One again, this is one challenge I feel a lot of people don't focus on is limited skills around the cloud itself, and how can we use some of these latest and greatest tools that are available. So again, I think that is one of the challenge in overall a data and analytics space, right? So these are some of the big challenges, and now let's talk about how Google handles some of these challenges, because most of those challenges, if you look at it, Google is a huge organization, so we have some form of other challenges as well. So let's see how we do it, right? So again, to give you perspective of Google, so we have about I'm pretty sure a lot of you have used google.com, right? So apart from that, we also have a lot of other uh, products, like about I believe we have about 5 or 6 products right now which are used by a billion plus users. A- Again, the idea there is, if you think about the scale of the usage of these products and how we have to support them, we have to break the traditional way of thinking and go into a newer way of thinking, right? For example, if you look at Maps or Gmail, how many users have been using it? How can I make sure my user gets the best experience, right? So again, 7 products that are powered with over 1 billion plus users. So with our experience, what we think from a smart analytics perspective is, the way you have to look at it is, rather than looking at it from a tooling perspective, start to think about more from a what are the things that I want to do, right? The first thing is you want to capture the data. So have a data ingestion strategy in place. And things that you want to consider in the data ingestion strategy are few things, right? One is it should be able to ingest any type of data. As I said, ingesting different types of data is extremely critical for your strategy, because today we have JSON, today we have PubSub, today we have Kafka, and again streaming services. But tomorrow you never know what would be the next mode of data transport, right? So having that ability to architect or to think about your ingestion strategy, where you are covering everything that you need today, but also having scope for newer things, right? Again, have a very good ingestion strategy, where you the idea there is to capture the data as it comes without any loss of data. So pretty much your raw data itself. And today, if you ask me, think about supporting streaming, supporting batch processing, supporting even real-time video streaming services, if that is something that applies to your business, right? So once you capture, what do you want to do with that, right? Because you're getting all the raw data, and that raw data, you want to have a process. Again, this process is not just transforming or ETL or anything like that, right? This process, you want to think about, is this data relevant? Is this data is what I'm expecting it to be? How do I govern this data, right? Because think about what kinds of data you are going to get, right? So again, you want to have a process in there where you can actually do multiple integrations. If you're getting data from multiple sources, having the ability to integrate all of them, again, all of this in real time or batch. You want to have tools, you want to select your tooling strategy such a way that you can support all of these. And finally, now that you got the data, you process the data, you want a place to store this data, right? For both long term and short term perspective. The long term strategy, I feel in this case that is relevant is, if you think about it, if you look at like the history from last 15 or 10 years, right? A lot of things changed, but you still have some intelligence that is in old data. So you want the ability to store the data, and also, given that the cost to say store 1 gigabyte per month is in cents these days, right? So the cost of storage has extremely gone down. So rather than deleting or purging the data, I strongly suggest put it in a archival mode, right? That way you still have the data if you need for whatever reason. Again, I'm talking about raw data. I'm not talking about logs and stuff like that. And also active data, right? So this is what we call hot or warm data. So think about more like a data warehousing environment or a data lake environment, right? Where you have a combination of a data warehouse structured data with a non-structured data, right? Again, a good combination would be a data lake plus a data warehouse called a lake house kind of stuff. And finally, now that you have an option to store the data, how do I analyze this data, right? Again, analysis, this is where you can go two routes. One is the traditional data warehousing where you have standard reporting, either using Tableau, Looker, or any of the tools that are out there. And the other one could be machine learning kind of analysis, right? Where you are feeding it the real-time data and asking it to scale or asking it to learn and asking it to learn as the data is changing and reduce your machine learning models drift and stuff like that, right? So, and finally, you want to use all this data using whatever reporting you want to do, right? Again, you can do using Google Sheets with embedded tools and stuff like that, Looker. Again, you can build models which can be then exported into TensorFlow and stuff like that. Again, if you look at this is how I think from a smart analytics platform. I'll give you an example in a second here. Is we worked with a electric provider, right? Again, this is a global electric provider in the US, right? It's a big one. And what they do is they have these IoT devices that are spread across every house, and they literally get real-time data monitoring on how many units are being used, stuff like that. So all of the data is streamed in, and then they process all of the data comes in a JSON format, and then they process the data, make sure that there is no missing data. Sometimes this happens, right? Because of whatever reason, the meter stops sending the data or it misses some beats, so you have some missing data in there. So you have the process layer in that case handles scenarios like, do I have missing data, do I have all the transition, am I getting ABC? Because sometimes the data flow in streaming, this is always a challenge, right? You want ABC, but sometimes it comes as CBA, right? So having all of that, maintaining all of that, again, we do that in the processing layer, and then you store that in the BigQuery in this case. And finally, they do analytics on top of that, right? So basically, am I seeing any maintenance issues, or am I using machine learning the forecast, is this device up to date, is this device having the latest firmware, stuff like that, and do I need any maintenance on this device, stuff like that. And finally, you have a lot of reports that are being published, right? Again, this customer has millions, I think 4 to 5 million devices sending in data every 10 seconds or so. And if you think about the scale, again, that is another thing that is important when you're thinking about your strategy. Think about your scale, think about what the future might look like with new tools coming every single day. How can I architect it such a way that it supports that? And also, how can I pay only as you go, right? So even in all this streaming, even with this architecture, you do not want to commit for anything that you're not using, right? So there might be one point in which you might have millions of devices. Maybe a few months down the line, you might not need millions. So you should always think about going more of a pay as you go model. Overall, that's how the cloud itself is. But think about when you're making any commitments in that way, right? So again, we have a lot of tools around this. So just to capture some of them, right? Again, in the capture place, if you are using any streaming, you can use Kafka, PubSub, and also if you have a large amount of data that you want to do, you can use a storage service. And then in the process phase, we have data flow, data proc. I'll talk about them in a second, and data prep, where you can use it to make sure you're actually integrating the data, prepping the data, and stuff like that. In the storage space, you can have BigQuery, which is our data warehousing platform, or you actually can store data in cloud storage. Cloud storage is our storage way, right? So it's our object storage, so you can store there. And the analyze phase is pretty where you can use machine learning. Again, within BigQuery itself, we have a lot of support for machine learning. It's called BigQuery ML. I'll talk about that in a few future slides. But a couple of things I want to talk about from going from that point on to the next, right? Again, the bottom layer is where you see all of that, right? So when you look at from a different personas on which people might be using which, right? So if you think about it, data engineers, machine learning engineers, developers, all of them are more towards your left side of the picture here, right? So at any time where you're massaging the data, where you're gathering, trying to integrate data, trying to collaborate, trying to have some governance checks and stuff. And as you move towards the right side here, you're going to see actual business users, business analysts use your products, right? So the reason I think this is important on understanding which layer is being used by which persona is the type of product you want to use, right? For example, if your end user is going to be a business user, you want to give him a dashboard but not expose him to tools where he has to write SQL, because they might not have that capability, and that's not what they are expected to do, right? Give them a dashboard, or give them a place where they can type something like they do in google.com, right? So what are the sales for the last 10 years, or what is the sales for this specific store from this date to this date, something like that, right? And then have intelligence built in where that can pull that up. So I think that is extremely important. And thinking about which layer, which persona, who are your users going to be in this layered approach or stacked approach, is going to be extremely important for you to kind of think about it. And also think about, I think, yeah, again, one thing towards the bottom of here where you say enterprise capabilities, that's towards the end. I think that is something a lot of people overlook, especially from an enterprise standpoint. Think about these things, right? Like, how are you going to, with a lot of data coming in, with, as we said, with especially smart analytics, every device is going to send you a lot and lot of information. We are talking about terabytes and terabytes, or even going into petabytes of information. So how are you going to catalog all the data that is coming in? How are you going to control who has access to what? That is IAM, right? And how are you going to make sure how, what type of encryption you are going to use? CMEK is customer managed encryption key, right? So basically, who is going to encrypt the data? Where is the data going to be encrypted? Who are going to maintain keys and stuff like that? Again, these things, especially in the smart analytics world, I think are not truly understood. So I think pay close attention to some of these as we are going into, again, disaster recovery, right? Again, what happens if the place where you are hosting goes down? Again, all, as I said, I worked with multiple cloud providers. All cloud providers at some form, at some time, had a downtime, right? So think about, what am I going to do when my cloud provider is down? What is my strategy going to be there, especially with smart analytics? A good example with this electric provider I was talking about, they were sending data in, but if the cloud provider is not ready to receive, what would happen to that data? You don't want that data to be gone missing, right? So have a strategy to handle that kind of scenario, right? It could be at the source side, you have some buffer where you can store the data or stuff like that. But think about scenarios like that. So again, that is kind of the overview from a smart analytics perspective on how I think we are heading towards. Now I'm going to talk about some very specific Google services that can help you with this strategy, right? So the first one, as I said, is cloud storage. The idea with cloud storage is very simple. You should be, you have any type of file, right? Any type of file or object that you want to store within GCP, you should have a very simple API that you should be able to upload the file, and the file should be accessed within sub millisecond when you first access the file, right? So if you are uploading a file and you want to access it, it should be as the latency should be as minimal as possible. And the third one, again, it's good that you are having this ability to upload a lot of data, but if you don't need it, you should also be able to delete it. And also, if you want to have some kind of life cycle policy, right? So let's say I upload a new file, like for example, the meter reading is a good example, right? So I uploaded the meter reading. Now that I ingested already into BigQuery, I don't really need the JSON that I got in, right? So maybe I just store it in a temporary storage, or I have a lifecycle policy which says the raw file is going to be there only for 30 days, and then I want to delete it, stuff like that, right? And in the process layer, you are doing a lot of temporary jobs, a lot of temporary files are being generated. So you don't even maybe need that policy at all. Whereas in certain regulatory scenarios, you want to actually store those raw files for 7 years or 10 years kind of scenario. That's where you want to have the life cycle policy kind of support, where you can say, okay, this file is going to be staying for 7 years. This file is going to be deleted after 30 days, kind of that kind of support, right? And again, which integrates overall into your cloud strategy, right? In this case, cloud storage integrates pretty much into every strategy, or it is one of our core storage services, so it works pretty well. And other thing you want to think about, as I said, going in as well, it's a cost. So where do I store this file that I'm getting in, right? So we at Google, at GCP in cloud storage, have multiple places, right? One is multi-regional. So we have multiple, like you have multiple regions across the world. You can store the same file in multiple regions. Again, the use case for this could be, if your users are going to use the file from multiple locations, you want that to be available to them with minimal latency. That could be multi-regional. Again, the cost wise, the left side is the highest, right? Multi-regional is our highest, versus the cold line is our slow, our cheapest, right? So think about what would be the right storage strategy for you. Again, you can start off with one storage class. So for example, if you have a new video file or something like that, you could start to do it in multi-storage, multi-regional, and after 30 days you could move into regional. After 90 days you could move into real time nearline, and after 1 year you could move to cold line, right? So you could have, that is what a life cycle policy, right? So you want to think about how that is going to be used and how it is going to impact your strategy. Again, this is important. Though storage is cheap, believe me, as data gets in, especially from your smart devices, it is going to add up very drastically if you do not have a very strong IoT policy, a very strong life cycle policy there. The second tool I want to talk about is Dataproc, right? Think about Dataproc more like our managed service for Adobe, Apache Hadoop kind of and Spark kind of offering, right? So in this case, the idea we had is we as we were working with customers, we saw that every time they had a lot of struggle or a lot of time was being spent spinning up these Hadoop and Spark, and making sure that infrastructure was ready was taking a good amount of our customers' time. So rather than having them to do, what we came up with, we said, okay, let's do Dataproc, where the customer just can come in, use Dataproc, and we will get, as I said, it's all managed. We will give you all the results. We have ephemeral as well, right? Ephemeral, where you want, if you want small clusters on demand, we again provide that for you. So if this is something for you from more like a processing layer that we were talking about, think about using Dataproc. Again, I think this should fit very well into what it is. And as I said, it is fast, it is very easy to use, and it's very cost effective. So you're only going to be charged for the time you have it, right? Again, this is more than from the processing and uh, processing, right? Again, data prep is, again, this is where you take that raw data and convert it into a format that you want to prepare it for your analytical processing or for your ingestion into your data warehouse, right? It could be used as a data prep tool, for a preparation tool for both warehousing, machine learning, analytics, whatever, right? Again, I think it supports pretty big variety of sources, and also it can make you some recommendations based on the type of data that you're getting. Again, based, if you're having a CSV, it can say, hey, you're getting different forms of dates. Why don't you convert them and standardize that into a really nice standard format, right? So stuff like that, and it is GUI based, right? So some people write GUI based without any coding. But again, if that is you, I think again data prep might be a right tool for you. Again, very strong. Like if this is a very simple example, right? You just throw in the data and ask it to give you some recommendations, and it will be a great start. Like you can throw in log files and say, okay, I want to parse this log file. Give me some recommendations, kind of stuff, right? Again, I think that's great. The idea with this data prep is, we found that the reason it exists, to be honest, is we found like business analysts have their own world and data scientists has their own world. So we are trying to bridge that gap where we can use the technologies to suggest some tools to you, at the same time use technology to make sure we are doing the right thing with your data, because you know your data better. So the other one is again data fusion, right? Again, this is more of an integration tool where you want to build or integrate data from different formats, or it could be data from multiple sources, and you want to make a club of all this data and make a offering, right? Or make club all the data to gain more intelligence, right? Again, this I see is very useful, especially from deriving more value from your existing data, right? So think about how can you use that again, right? So think that it helps you with our basically things like do finding duplicates, transforming ETL kind of stuff, and also it has some visual tools built in where you can help with testing some of these, and also we obviously have some kind of monitoring and stuff, right? Again, these are sort of found out there with all these tools. The idea there is to help you concentrate on the logic and help you concentrate on gaining intelligence out of your data, but trying to get out of trying to make sure the data integrates well, stuff like that, right? Again, that is pretty much a data fusion is, as the name suggests, it's more of a integration. I like the names because the name itself tells you most of the time what the tool does. So BigQuery, again, I'm going to end with BigQuery. I think I have one slide for Looker towards the end, but with BigQuery, though we call it more like an analytical data warehousing tool, it has a lot more capabilities, right? If it is definitely a data warehouse, the reason is if you look at the underlining, if you open the hood and look at the what's beneath that, it is a very strong underlining. Postgres is what it is based out of, right? Again, it has a lot of tools built into that, and it is fully serverless. This is one thing that I think it's extremely unique with BigQuery is you don't have to tell me, okay, I'm going to have 10 terabytes of data, because data, as we said, is always increasing, especially with smart devices, right? You never know how to predict the data. So you want something that scales as data comes in. So I think this with BigQuery, it is very unique that it is a fully managed service. And the second thing I think is important is it can give you a lot of batch processing. So if you have a data warehouse where you want reports that are generated every Monday morning, stuff like that, it gives you that. At the same time, it also gives you, you can directly ingest real-time data into BigQuery and then get insights not only from real-time data clubbed with your historical data. I think that is good. Then. And machine learning is another thing. I think there is one slide right next about this. But the idea here is we know that we have a lot of developers who are good with SQL. So the idea is how can I take that and use my machine learning? How can I take the SQL knowledge and then add machine learning on top of it to make it very useful, right? So that is what is auto ML. So if you give BigQuery your BigQuery table and say, okay, I want to have some machine learning models run on this and tell me what I should predict, you can actually do that, and then you can actually more like add a column kind of stuff with machine learning built in. That is really good, I feel, because again, you don't, as a SQL or data people who have been working very strongly with the data, you don't have to spend a lot of time learning data, but learning machine learning, but you can use that heavily. In memory BI engine, again, this is very useful, especially the more in memory you have, the faster your queries are going to run, right? So again, I think that is pretty much how we do that. And this architecture, I'm not going to dive deep, I know we are running a bit late here, right? The idea, how can we do all of these amazing things, how can you scale without telling how much data you have and all of that? The answer is very simple. You basically, what we do with BigQuery is your compute and your storage are kind of two different components to it. So as your data grows, you grow your data side of the things, right? And the compute side comes only into picture when you start to write queries, and you pay basically per query, right? How much data you scan and stuff like that. Again, BigQuery ML, as I said, is extremely useful, where it enables data scientists to directly put machine learning into SQL. BigQuery GIS is useful, especially if you have geopolitical data, sorry, geo location data. So if you have where your customers are, if you're capturing that data, you actually can use BigQuery GIS and then use Google Maps on top of it, right? You know, that way it can give you not only data analysis, but also can give you some geo analysis on how much time it is taking and stuff like that. Connected sheets, if you are using Google Workspace or Google Sheets, there is an easier way where you can, it's basically connected sheet is nothing but Google Sheets, right? It gives you a way where you can directly plug in your BigQuery, right? So through Sheets, you are able to analyze petabytes of data just by using Sheets. So I think that is amazing, especially for your business folks who are already well versed with Excels and Google Sheets, where they can use this connector to connect directly into BigQuery. BigQuery ML, as I said, I'll just do in two steps, right? You have your data set, then you create a model within BigQuery, and again using that something like a create model ABC, and then you evaluate the result, and finally, once you have that model, you then start using that model within your queries. I know, again, Looker is where you actually use that visualization of all your BigQuery. So as I said, BigQuery is serverless, right? There is nothing to manage. On top of it, we have this visualization tool, which can actually, Looker is our visualization tool, which can directly integrate with BigQuery to kind of show you all these amazing, nice data experiences that you have. You can build stories, you can build dashboards and whatnot, and you can do a lot of customization. Looker also has something called a Looker ML kind of stuff built in Looker. Again, this is on the dashboarding side. This could be used for forecasting and stuff like that, right? So, and also I didn't dive a bit deep into Looker, but Looker has a very good caching layer, and also it has a semantic layer, right? That way your business users really don't know which table the fields are coming from, which I think is important, especially from separation of duties kind of stuff. Again, with in perspective for smart analytics, if you think about it, taking that data from silos and trying to merge all of that data and trying to find that analytics using BigQuery and then reporting that using Looker, I think is the way we have to go if you're if using a Google Cloud stack. I think. That's all I had, Ron. Sorry, I think I ran a bit over.